So in this video, we are going to summarize the chapter Complex Numbers and Quadratic Equation. A complex number is of the form a plus ib, and we will represent z as equal to a plus ib, where a is called the real part and b is called the imaginary part. If a is equal to 0, we are getting z is equal to ib, which is purely real number. And if b is equal to 0, that means if b imaginary part is 0, we are getting z as a, which is purely real number. So a complex number is represented by a plus ib, where a is the real part and b is the imaginary part. The value of I is equal to root of minus 1, and we have seen the powers of I square, the value is 1, I cube. To find I cube, what we will do, we will write it as I square into I square is minus 1 into I gives you minus I. If the power is an even number, if it is 24, how we will write? Take the half of 24, that is I square raised to 12. I square is minus 1 raised to 12 gives you the value 1. In this way, we can calculate any integral power of I. Again, if I want to add two complex numbers, for example, if I want to add 2 plus I3 plus 5 plus I5, what I should do is add the real part and add the imaginary part. 5 plus 2 gives you 7 and 3 plus 5 gives you 8. Since it is the imaginary part, we have to write I8. Okay, similarly, we can subtract the complex numbers. To subtract, if this is the same complex number, 2 plus I3 minus 5 plus I5, to subtract, what should we do? 2 minus 5 gives you minus 3 and I3 minus I5 gives you minus 2I. This will be the subtraction. Similarly, we can multiply two complex number. If I want to multiply 2 plus I3 into 5 plus I5, what should I do? As usual, we should open the bracket. 5 into 2 gives you 10. 2 into I5 gives you 10I. I3 into 5 gives you I15 or 15I, and I into I is I square, which gives you negative 1, and 5 into 3 gives you 15. 10 and minus 15 are the real parts. Simplifying, we will get minus 5, and 10I plus 15I gives you 25I. This is how we are multiplying two complex numbers. If I want to divide two complex numbers, suppose I want to divide 2 plus 3I divided by 2 plus 7I. What should I do? I should take the conjugate of the denominator and multiply with the numerator and the denominator and then simplify. So 2 plus 3I into the conjugate of denominator is 2 minus 7I divided by 2 plus 7I into 2 minus 7I. When we divide the denominator and the numerator with the conjugate, the denominator will be of the form a plus b into a minus b. So numerator you can do like this. Just expand using ordinary multiplication, and the denominator becomes a square minus b square, that is 2 square minus 7I the whole square. 7I the whole square is actually 7 square into I square. 7 square is 49, I square is negative 1. So this will become 4 plus 49, and you can simplify and write it as the form a plus ib. To find the square root of a negative number, suppose I want to find the square root of negative 3. What should I do? I want to separate it as root of minus 1 into root of 3. Root of minus 1, we know the value is I, so we can write it as I root 3. Okay, so if I want to write minus root 27, root of minus 27, I can directly write as I into root of 27. From where I got I? This can be written as root of minus 1 into root of 27. Root of minus 1, instead of that I gave the value I. So I can rewrite it as I into root 27. The next what we dealt with in the chapter is modulus. To find the modulus, suppose z is equal to a plus ib is a complex number. Modulus is written like this, and the formula is square root of a square plus b square. Square root of a square plus b square. Modulus is actually the distance of the point from the origin. Okay, so modulus of z is equal to square root of a square plus b square. And the next step what we dealt was the conjugate. What is the conjugate? If I am taking the complex number as a plus ib, its conjugate is written as z bar, and the conjugate is given by changing the sign of the imaginary part. Here the imaginary part is positive, so if I change the sign, I will get a minus ib. So it's z bar, the conjugate is a minus ib. To find the inverse of a complex number, inverse of a complex number is represented as z raised to minus 1. We have a formula. Z inverse equal to conjugate of Z divided by mod Z square. So in this case, conjugate of Z is A minus IB divided by mod Z is root of A square plus B square. We need the denominator as mod Z square. So we are getting the denominator A square plus B square. And if I want to express in the form A plus IB, I can rewrite as A by A square plus B square plus I into B by A square plus B square. Instead of studying this much, study by heart the formula inverse of Z is equal to Z bar by mod Z square. Conjugate of Z by modulus of Z square. Again, if I take the conjugate of a complex number twice, that means Z bar the whole bar will be equal to Z. That is one of the property. Z bar the whole bar is equal to Z. Same way, if I am writing Z as A plus IB and Z bar as A minus IB, what will be Z plus Z bar? Z plus Z bar, we have to add these two, isn't it? IB and minus IB get cancelled, giving you 2A. A is the real part. So, real part can be rewritten as, real part of the complex number can be rewritten as complex number plus its conjugate by 2. Okay, suppose I am subtracting these two equations. So, what I get? Z minus Z bar is equal to, the sign of the second equation gets changed. So, A becomes negative and A and minus A get cancelled. Minus IB becomes positive. So, IB and 2IB will give you, IB and IB will give you 2IB. Okay, from this if I want to calculate B, how should I write? Z minus Z bar by 2I. So, for a complex number, real part can be written as Z plus Z bar by 2 and the imaginary part can be written as Z minus Z bar by 2I. Z minus Z bar by 2I. For any complex number, if I am taking a complex number 2 plus I 3I, there exists a point in the plane, isn't it? So 2 plus 3I can be represented as, if this is 2 and this is 3, this point represents the complex number 2 plus 3I. X coordinate will be the real part and Y coordinate will be the imaginary part. So for each and every complex number A plus IB, there corresponds a point A comma B. Okay, in the plane. And modulus of Z, as I told earlier, modulus is the distance of the point from the origin. For example, if I take the modulus of this complex number, that is actually the distance of the point, distance of this point from the origin. That is modulus of P. Again, the next what we dealt was a polar representation. To represent a complex number in polar form, what I have to do is, the polar form is Z is equal to R into cos theta plus I sin theta. What is R? R is actually the modulus and theta is the amplitude. Polar form is also termed by the name modulus amplitude form. Modulus amplitude form. So, R is the distance of the point from the origin. So, in this figure, this is R. Okay, or the modulus. And what is it? Theta. Theta is the angle formed by the line with the positive direction of x-axis, that is theta. So, polar representation is Z is equal to R into cos theta plus I sin theta. To represent a complex number in the polar form, we have to calculate the value of R using the formula square root of A square plus B square, and we have to find theta. Theta is given by the formula tan inverse of B by A, where A plus IB is our complex number. And the next what we dealt in the chapter is a quadratic equation. Quadratic equation we have already dealt with it in the 10th standard. Here also we are finding the solution. What makes the difference is we are finding the solution in which no real roots are there. For example, if I am finding the value of x using the formula minus b plus or minus square root of b square minus 4ac by 2a, if b square minus 4ac comes in the 10th standard, we wrote the answer as there are no real root. But in here, after finding the complex number, after studying about the complex number, we are able to solve till the end. How we will solve? Suppose you are getting b square minus 4ac as minus 7. So, root of b square minus 4ac can be rewritten as 7i. Okay, so that the complex number x value will be of the format minus 3 plus or minus 7i by 2, something like that. So, for each and every quadratic equation, we have a solution. Either it will be a real number or it will be a complex number. All real numbers are complex numbers still. Sometimes there will be I after taking the square root of a negative number, otherwise I will not be there. Okay, so this is the only difference between the solution of quadratic equation which we studied in the 10th standard and now. And the last section which we studied in the chapter is to find the square root of the quadratic equation. To find the square root of the quadratic equation, we have to remember 2-3 steps. The first step is write the square root of the given number in the form x plus iy. Write the square root of the given number in the form x plus iy. Second step is square both sides. When we square, the left side square root will go and right side it will become x plus iy the whole square. Expand the right side. So we are getting x square minus y square plus I into 2xy. Then we will equate real part and imaginary part. So we will get the value of x square minus y square and also 2xy. After getting x square minus y square, what we will do is we will apply a formula x square plus y square the whole square is equal to x square minus y square the whole square plus 2xy the whole square. From this we will be getting x square plus y square. We will simplify these two equations to get the value of x and y. X and y will be having positive and negative values. Both x and y will be having positive and negative values. We took the square root as x plus iy. X is having positive and negative value, y is having positive and negative value. So which value we have to take? That depends on the sign of the 2xy. If we are getting 2xy as a negative value, 2xy if it is negative, if we take x as positive, y must be negative. That means sign of x and y must be different. If 2xy is negative, x and y must be of opposite sign. If 2xy is positive, x and y must be of same sign. Okay, that is the only thing you have to notice here. The all other steps remains the same for each and every question. And again, how we are getting this formula? We have an identity a plus b the whole square. What is a plus b the whole square? It is a square plus b square plus 2ab, isn't it? And what is a minus b the whole square? A minus b the whole square is a square plus b square minus 2ab. Okay. So if I am writing a plus b the whole square in terms of a minus b the whole square, can I write that? A plus b the whole square is a square plus b square plus 2ab, isn't it? So if I am adding minus 4ab to the right side, I want to subtract that term also. So plus 4ab. So this will be, what about these two values? I am simplifying these two values. So I am getting a square plus b square minus 2ab plus 4ab. I just simplified 2ab with the minus 4ab. So what about this value? A square plus b square minus 2ab gives you a minus b the whole square. So a minus b the whole square plus 4ab. That is how we are getting a plus b the whole square is equal to a minus b the whole square plus 4ab. Okay, here instead of a it is x square. So what we will get? X square plus y square the whole square is equal to, right side is x square minus y square the whole square plus 4x square y square. So that is x square minus y square the whole square plus, instead of 4x square y square I can rewrite as 2xy the whole square. That is how we are getting the formula x square plus y square the whole square is equal to x square minus y square the whole square plus 2xy the whole square. No need to by heart all these steps, just by heart the formula x square plus y square the whole square equal to x square minus y square the whole square plus 2xy the whole square, and simplify these two equations, which are x square minus y square equal to some value and x square plus y square equal to some value. Find the value of x and y. X will be having positive and negative values. Y also will be having positive and negative values. To choose the whether it is positive or negative, you have to go for the sign of 2xy. If 2xy is negative, x and y will be having different sign, and if 2xy is positive, x and y will be having same sign. Okay, so this is altogether the chapter complex number is about. Okay.